Hi, and welcome to another Axual release update. In this update we will show highlights of the latest Axual release. We will show you how you can speed up development, incident resolution and testing using Stream Browse and Search, how you can hook up external systems to Axual, and how you can maintain schemas for your streams using Schema Upload. But first, we would like to cover something different. From this release we have adopted a new version scheme. We are moving from an arbitrary version number, being 551 for the latest release, to a less arbitrary version number. Our version numbers will now contain the year of the release in 4 digits, followed by a sequence number. With 4 releases planned yearly, you can expect a 2020.1 until 2020.4. This new version number is easier to understand and remember, and you can more easily identify how much you are behind on the latest release. Now, let's take a look at what Axual 2020.1 offers. One of the most awaited features requires a bit of introduction. When you're building an API or just another business application, you move your app through the software development lifecycle, or SDLC in short. In this lifecycle, your DevOps team is responsible for testing the app in various environments, moving your app from dev to prod. In all those environments, your app needs to pass essential tests before you move to the next environment. Now, when you are testing an API, you might do some automated REST calls to your app to verify it's working in a particular environment. However, if you are building a streaming application, this is a different story. Meet Team Rocky, a development team which is working on a streaming use case. Team Rocky is building a producer app, producing alert events to a stream. Team Rocky is building their app. They have decided on a schema format, they have uploaded it using self-service and registered it on the stream. However, when they produce messages to the stream, they are not 100% sure whether those messages have really ended up on the platform and whether the contents is as expected. Consuming the message from the stream would give them confidence that what is produced actually ended up on a platform. But building a consumer app just to verify this requires a bit too much effort. Wouldn't it be great if Team Rocky would be able to verify this themselves, without building anything? We think so. That's why we introduced the Stream Browse and Search feature, which can be found on the Stream Detail page. Stream Browse and Search allows you to browse or search for messages on a stream in a given time frame, using a keyword you specify. And, of course, we support the software development lifecycle, because you can select the corresponding environment in a drop-down. The search results are shown in a list, which can be paginated. By clicking a single record, it is expanded to show a more detailed view about the message contents. You will also find header information there, which can be useful for debugging purposes. Any header that you insert using your client application will be visible here. So, any team can now easily verify whether the messages they have produced have really ended up on the platform using Stream Browse and Search. Access to a stream's messages is granted based on the following permissions. If you are a stream owner, you can access messages on streams you own. If you are a tenant admin, you can access any stream's data in any environment. If you are an application owner of a connected application, you can access any stream's data in authorized environments. We have highlighted an advantage of this feature for producers, but a consumer would also benefit from it. First of all, before they even start building their consumer app, they can get a sense what kind of data they can expect on the stream by inspecting the schema or looking for some actual messages. Secondly, as soon as their app is live and it crashes because of an unexpected message, they can use Stream Browse and Search to find the message that is causing a problem by narrowing the time window. When you're using a streaming platform, it is advised to use Schemas as a contract for your data streams. You can do so with multiple formats, Avro being the most popular and widely used currently. For a very long time, Axual has support to use Avro for your data streams. When creating a stream, you can already select the schema to be used, and depending on the environment, you can even select a different version of the schema. Now, those schemas are coming from a jar file, a collection, which is uploaded to self-service using a REST call, which is a bit cumbersome. As of Axual 2020.1, this has become a lot easier. You click Schema Upload in the main menu. You select the Avro source file, usually with extension AVSC. The schema is then shown in a convenient viewer. In the background, both the Avro syntax is checked and a compatibility check is done to make sure the new schema is backwards compatible with the previous one. Using the viewer, you verify that the contents of the schema is according to your expectations. You enter a description of the schema, which helps users to understand what payload the schema is describing. You put in a version of the particular schema, and you click Upload to upload the schema. From this moment, the schema has become available for registration, which I will show you right away. When you navigate back to the stream configuration, you will see that the newest uploaded schema for Alert event has become available for use on a stream. It is displayed here in the dropdown. With this method, you can not only upload entirely new schemas, but also new versions of existing schemas. With the automatic compatibility check, you are ensured that consumers remain working if you decide to upload a new version for an existing schema. There are many ways to get data in and out of your streaming platform. How you do this really depends on a lot of things. One of this is whether you have support to add custom code. In some situations, you cannot really add custom code or components to an existing system, which makes it hard to let that system produce data to a streaming platform. Think of cases such as handheld, lightweight IoT or legacy mainframe systems. In order for these kind of systems to communicate with the web, they use plain HTTP. Implementing applications on such systems is often limited by hardware specifications beyond the developer's reach, so they have to adhere to those. Now, the brokers in an Apache Kafka cluster do not support posting data via HTTP directly, so you will need another component to perform the translation for you. Here is where ResProxy comes in. You can use ResProxy to produce or consume a stream's messages, or register or fetch a schema for a particular stream in any environment. Authentication and authorization of REST clients is no different from regular custom apps that connect to Axual directly. It is based on mutual TLS, so they should use a certificate to connect to the REST proxy and trust the issuer of the REST proxy certificate. In a short demo, I will show you how you can produce and consume messages to and from Axual using ResProxy with simple REST calls. In this short demo, I will produce fictional incident events from an external system to make them available for analysis to any consumer interested. What I've set up here is a small script which generates the JSON payload of a message to be sent to ResProxy. It takes two arguments, incident ID and severity of the issue. I will now generate a random incident with a certain ID and severity. The payload is shown here. I will now execute the curl request a couple of times to produce some incidents. The ResProxy returns some information in the response, such as the cluster, the offset, where the message is stored, the timestamp and the partition. We can now easily validate whether the messages indeed have been produced. Of course, I can do this using Stream Browse and Search, but to demonstrate ResProxy, I use a simple consumer script. I will only show the curl request. The remainder of the script is largely the same as the producer. Please note that there are some different headers to be passed to ResProxy. I will now start the consumer script in loop mode to see messages coming in via REST. ResProxy has full support for Avro as well. You can read more about this in our updated documentation. One last thing worth mentioning is that compared to existing REST interfaces for Apache Kafka, you can create a producer and send the payload in just one request. This makes Axual ResProxy much easier to use. That's it. Thanks for staying with us. I hope you are as excited as I am with this set of tremendous features, the result of a huge team effort. All of the shown features have been carefully documented in our online documentation. However, if you can't find what you need, feel free to open a support request. In this release update, we have shown you some exciting features that help you to develop your streaming use cases, and more importantly, help you to create business value from your streaming data. All of the features we've shown are part of Axual Cloud, from the moment we've posted this video. If you want to try Axual, please click on the button that is shown. If you want to learn more about Axual, please subscribe to our YouTube channel or contact us. For now, thanks for watching.